Good morning all. Today we discuss the next part of basic mathematics for our mechanics course. Now we discuss the base vectors. Base vectors are a set of orthogonal unit vectors, one for each dimension. In the previous lecture, when we discussing about the components of a vector, we use the three-dimensional Cartesian coordinate system. Here, we use the same coordinate system, that is the three-dimensional Cartesian coordinate system. In that case, the base vectors lie along the x, y, and z axis. And the unit vectors in each axis denoted as I cap in x direction, j cap in y direction, and k cap in z direction. And there are some properties for the unit vectors. That can be discussed as follows. Here, the scalar dot product of the same unit vectors gives the result 1. That is, we can obtain I cap dot I cap. That is equal to I is the unit vector. Then the magnitude must be equal to 1. And here also unit vector. Then the magnitude must be equal to 1. Then there are same vectors. Then the angle between them is 0. Then it is equal to 1. That is 1 into cos 0, that is equal to 1. In the similar way, j dot j must be equal to 1 and k dot k must be equal to 1. J dot j is equal to 1, k dot k is equal to 1. And the product of I with j. The product of I with j. There are unit vectors. They are unit vectors. I is in the x direction, j is in the y direction. Then the angle between I and j is 90. Then 1 into cos 90. Cos 90 is equal to 0. Then the result is 0. Similarly, if we find j dot k, it is 0 because of cos 90, and k dot I must be equal to 0. I dot j is equal to 0, and similarly j dot I also is equal to 0, and here j dot k is equal to 0, and similarly k dot j is equal to 0, and I dot k dot I is equal to 0, or I dot k also is equal to 0. And when we considering the cross product, when we taking the cross product means it is a vector product. That is, when we evaluating I cross j, I cross j, I is in x direction, j is in the y direction, then the direction of I cross j, it is mutually perpendicular to x and y direction, that must be in the z direction. Okay, then the unit vector in the direction of z, what is it? It is equal to k. Okay, then it is equal to the vector, unit vector k cap. And the next one, j cross k must be equal to, here it is y and z direction. Okay, j cross k. Then we know that the I j k, they are making a right hand rule system. Okay, then we can remember this equation in a simple way. That is, first expression we obtained it as I cross j equal to k. Then using the cyclic permutation, that is, change I j and k in this order. Okay, then we will get the next equation. I is converted to this term. I is converted to j. J is rotation by 1. I is converted to j. J is 1 converted to k. Then k is converted to I. Then we get the next equation. And the next one, j is converted to k. K cross k is converted to I. Then that is equal to I is converted to j. It can be obtained by cyclic permutation. And here another set of expression can also be obtained. That is, we know that in the cross product A cross B, the vector A cross B not equal to B cross A. That is, the direction of A cross B and B cross A are different. We discussed in the previous class. That is, the direction of B cross A must be opposite to the direction of A cross B. Here the vectors are same, A and B, then the magnitude must be same. Okay. Then we can say that A cross B must be equal to minus of B cross minus of B cross A in the opposite direction. Then in the similar way, we can obtain the expressions of J cross I. J cross I cross J is equal to K, then J cross I must be equal to a minus of that one. I cross J is equal to K, then J cross I must be equal to minus K. In the similar way, K cross J is equal to minus I, and I cross K is equal to minus J. When we are dealing with vectors, you must remember these properties of unit vectors. It will be very useful when we manipulating the vector equations. So keep in mind these fundamental base vector equations. Using the base vectors, we can represent a vector A. We know that in the previous class, we discussed a vector A can be expressed using its components Ax, Ay, Az. Okay. That vector can be represented using the base vectors as vector A is equal to Axi plus Ayj plus Azk. So to find the component of a vector in any direction, we have to take the dot product with a unit vector in that direction. Consider an example. That is, we have to find the component of the vector A in y direction. So what we do? We have to take the dot product with a unit vector in that direction. In y direction, the unit vector is j cap. Then we have to find the dot product of A with J. Okay, then we know that A is equal to A vector is equal to AXI plus AYJ plus AZK. The vector is dot producted with J. Okay, we take dot product with each term. Then the first term must be equal to AX into I dot J plus AY into J dot J plus AZ into K dot J. K dot J. Okay. Then from the previous discussion, I know that you must remember I dot J, J dot J and K dot J. What will be the values of this product? I dot J is equal to 0, J dot J is equal to 1 and K dot J is equal to 0. Then the remaining quantity is only AY. AY is the component of A in y direction. So to find the component of a vector in any direction, take the dot product with a unit vector in that direction. Okay. So it is very easy to evaluate the scalar product A dot B and the vector product A cross B with the aid of these base vectors. Consider the vectors. That is the vector A is AXI plus AYJ plus AZK, and the vector B is BXI plus BYJ plus BZK. When we taking the dot product, that is taking dot product of A and B, substitute the value of A and the value of B. Okay, then we find the product of this term with this is B. The total, this quantity is vector B and it is the components of. Okay, then we take the dot product of AXI with B and then we find the dot product of AYJ with this one, and finally we find the dot product of AZK with B. Okay, then we sum it. Okay, look at here. First we taking the product AXI with B, it is B, and second AYJ with B, and by last AZK with B. Okay, then we taking product as we done before. That is, here it is the vector B and it is the component of this quantity. Then if we evaluate this quantity, I written here what we do, that is we take the product of AX with BX, AX, BX, and taking the dot product of I dot I, because of AX and BX are magnitudes. I and I, here I are vectors. So we take it is equal to AX, BX, I dot I plus the next product AXI with BYJ. Then we write it is AX, BY, I dot J plus AX, BZ, I dot K. Then look at this dot product. Which one of them 0 or 1? Here it is 1, it is 0, and it is 0. Okay. Then these terms vanishes, as it is here, it is I dot I is equal to 1. Then there is no vector quantities, only simply what quantities remains? AX, BX remains. And in here, the product AYJ with B. Then we return AY, BX, J dot I plus AY, BY, J dot J plus AY, BZ, J dot K. In similar manner, here it is 0, and here it is 1, and here it is 0. Then these quantities, this quantity vanishes, only the remaining quantities must be AY, BY, and it is also vanishes. And in the last product, it is AZ, BX, K dot I plus AZ, BY, K dot J plus AZ, BZ, K dot K. Here the K dot K must be equal to 1. The remaining dot product must vanish. This vanishes, only the remaining quantities AZ, BZ. Then we sum these terms, that is AX, BX plus AY BY plus AZ BZ. It is the last result. That is, it is the sum AX BX plus AY BY plus AZ BZ. Then we go to the cross product. Here also we consider the vectors as A and B, and we find the cross product. We substitute the values of A and B, and as in the previous case, we take the cross product of each term in A with B vector. That is, first we find AXI cross B and AYJ cross B and AZK cross B. We find the terms one by one. First we evaluate this one, and secondly this one, and lastly this one. Okay. First we take the product AXI cross product with B. Then look at this product. That is, what will happen? It is AX, as AX and BX are magnitude. Then here also we can take the product of AX with BX, and we take the cross product of I cross I. The next term AX BY, AX BY, I cross J plus AX BZ, I cross K. And look at the cross product terms. That is I cross I. What is the value of I cross I? What will be the value of I cross I? It must be equal to 0, because the angle between I and I must be equal to 0. So this term vanishes. And I cross J, the value of I cross J is equal to K. And what is the value of I cross K? I cross K is equal to minus J. Then we obtain AX BY K. AX BY K. Here is minus, then minus AX BX J. This is the result. AX BY K minus AX BZ J. When we taking AX outside, we get AX into BYK minus BZJ. Similarly, when we finding the next two products, we will get AY into BZI minus BXK, and the next product give AZ into BXJ minus BYI. Then combining the three results, that is the first one, second, and the third. We sum the three terms. Okay, first term is ax into by k minus bz g, plus second term ay into bzi minus bxk, and the third is az into bxj minus byi. Now we collected the different components. That is the component of the product vector. If A cross B is any vector C or something, we find the component of the vector C. Okay, then we have to find the component in X direction, Y direction, and Z direction. For that, we arrange the equations. That is, we collecting the coefficient of I cap and the coefficient of J caps and the coefficient of K caps. First, we collecting the coefficients of I cap. Look at just collect the coefficients. Here it is I, and the coefficient is AZ BY with a minus sign. Okay, and here AY BZ with a plus sign. Then AY BZ and AZ BY. Okay, then next we collecting the J components. Look at here A minus BZ and AX, and in the last BX with the AZ BX minus AX BZ. Okay, next we collect the coefficient of K, that is AX BY here and a minus AY BX. Okay, then this is the components. That is first component, that is the component in Y direction, and it is the component in the Z direction. Okay. These components can be expressed in a simple manner by the use of determinants. Have you heard it? Matrix and determinants. Okay. Then if we represent, it is a 3 by 3 determinant. Okay. Then first we write the unit vectors or the base vectors. I, J, K. And the components of vector Ax, Ay, Az. And in the next row, we write the components of vector B, Bx, By, Bz. Okay. When we evaluating this determinant, we know that we take this quantity I and we removing these row and column and find the product of Ay with Bz minus the product of Az with By. Then it is Ay Bz minus Az By. Okay. And in the next case, in the determinants, we put a minus quantity for J. Minus sign, a negative sign for J. It is from the algebra of the determinant. Okay. Then minus J into that expression is minus J into what we do? We avoid this. We avoid the row and column which contains J. Okay. Then the second term is evaluated as minus J into. Then the product of Ax with Bz minus Az with Bx. It is also equal to, it can be written plus J into, we multiplying this minus into the bracket, then this term must be negative and this must be positive. Okay, then it is Az Bx minus Ax Bz. It is this quantity. And in the last, K into Ax By minus Ay Bx. So using the base vectors, we can represent the cross product in a simple method. Next, we have to discuss the displacement and the position vectors. Now we stop here. We will discuss this in the next class. We have to discuss displacement and the position vector. Okay, thank you.